do ask your question. We have 45 minutes, so let's make the best out of it.
Okay, I realize like for my gaseous state, like my concepts are okay, but when I have to apply to real life situations, it gets very confusing.
All right, let's see. Let's see. Gaseous state. What's gaseous state for chem? Feels a lot like physics gaseous state.
Yeah,
right?
yeah, it's just physics, but
Right. Give it to me.
yeah, wait, I'm looking for it.
Calculator.
I put inside the Jamboard.
Right. So it should be, wait, which Jamboard? Because it should be the same Jamboard, right?
Same Jamboard, sure.
Page 7, right? Prepare for you.
Okay.
7. And
I have an idea of how to do it, but then the answer key says it does something that's very weird.
right. Yeah, I'm gonna plug in my headset. Wait, just make. Testing, you can hear me?
Yes.
I can hear you much better. All right. Inflator. Yeah, okay. Yeah, okay. Okay, sure. Okay, all right. Did they tell you what the laughing gas is?
No, I don't think we have to know. It's just a guess.
Okay. The person. Okay, you're showing me the answer key, right? So I'm gonna put it down here. Okay. Make it a bit smaller. Maximum internal pressure. Okay, sure. Right. Okay. Right. Okay. Yeah.
So I understand. Okay, I got this part lah. Then I understand this part, but I don't know why they are taking this minus this value.
All right. Okay. So, so that we deduce the 1.99, right, from the safe pressure difference, right? That's
yeah.
That is what we are aiming for as the limit. So then your 0.28, you're confused, right? But 0.28 is simply because the external pressure at the 10,000 meter height is 0.28. And that matters.
But then aren't you supposed to use like the, wait, I haven't seen this question in a while.
Right. Yankin, I can. Okay.
Let me see what to do.
Right. Yankin, I can see you. Can you hear me loud and clear?
Yeah, I can.
Okay. I prepared a Jamboard using the old one, right? Page 9.
Okay.
You're preparing for tomorrow's exam, right?
Yeah, math paper 1.
That would be math, right? So unless there's anything different, I'll just be answering your questions today. Yes?
Yeah, just math.
Okay. let's make use of the 45 minutes. Right? I'm looking at Keiko's, but I'm waiting for your Jamboard also, and for your question also. Right.
No. I took a different value. So I did use this. I don't know why they use this.
Right. Okay. So the 0.28 makes sense, right? Because that's external,
yes,
right?
yes.
And then the 2.84, which you found, right? When you find it, you should know that you should realize that that is the internal pressure of the balloon, right? Meaning from 2 bar, he went up to, from 2 bar, he went up to 2.84, basically. No?
Okay, okay, this is my working. I use this, then P2 equals to. Then I got this as the new like internal pressure.
Which is not 2.84 lah. So the 2.84 you didn't get, correct?
Yeah.
Okay, I'm just figuring out the 2.84. Huh? I don't think it makes sense at all, but I'm thinking for now. The only difference between, yeah, okay, great.
Not plus.
Calculate. Oh yeah. Of course, calculate the maximum lah. Of course, that's correct. Right? Of course, that's correct. No, the 2.84. So your question is here, right? So your question must be this one, right? Or is it this one? Sorry, which one is your question, by the way? Is your question this or is your question that? Because I think there's something wrong here. I think, if I'm not mistaken. But this one, I don't think is. I think it's fine. I think.
Wait, maximum.
I think this is okay. I think this is not okay. I think it's not okay. So Yankin, did you put anything on the Jamboard?
Yeah.
Okay.
I just have one question for this one.
Let me clarify with Yankin first. Okay, cool. Right. So yeah, good. Now your working will be zoom in. Okay, very nice. So you're just doing the dy dx. Okay, I mean, looks reasonable.
I did the dy dx for you. So I'm not sure the tangent approaching 0 and tangent approaching pi was it.
Right. So when they say approaching 0, sometimes you basically simply put 0, right? So cosine 0 would be 1 minus 1 over 1 plus 1, right?
Yeah.
So I think, yeah, as long you say that the tangent approaches 0, I think your presentation a bit off here. So you must say that the dy dx approaches 0 as t approaches 0. Therefore, you say straight line. No? And it's not a straight line, it's also a mispresentation. It's a horizontal line. Straight line can have a gradient. Sorry. A line is always straight in math. So you should be saying horizontal. Is that what you meant?
Yeah.
Okay, so the presentation should be like that. Now t approaching pi?
That one I'm not sure.
Pi is 180, right?
Yeah. So
180. So dy over dx approaches what as infinity, right? Approaches.
Let me see. Cosine pi.
1 minus 1 over 0.
1 minus 1 over 0 is 2 over 0.
Yeah, which is therefore dy dx approaches
infinity.
Yeah, infinity. In this case, it's a positive infinity, I believe. So it will be a, I mean, doesn't matter. So it will be a what?
So it'll be a asymptote.
No, don't say asymptote. No. Well, yeah, no. He's asking about the tangent. He's asking about tangent. So just explain what the tangent becomes. And yeah, the tangent becomes a vertical line.
Oh.
Of course, that point becomes an asymptote. I agree, but he's just asking the tangent, right? Okay, so for you, Keiko.
Okay, yeah, I finally remember. So
yeah.
I found the actual internal pressure of the balloon.
Correct.
So I'm supposed to take that minus the external pressure.
I agree.
But
I agree with
the maximum
correct.
internal pressure.
I'm also thinking like that. So I'm just going to slowly check one by one before I finalize my conclusion. I think he's a bit off. I think he's a bit off.
The answer key.
I think the 2.84 is off lah. I think. Right. I think I'm going to read slowly. You don't wait for me lah. Just post the next question. So
I'm getting the next question.
Right. So for you, Yangin, are you okay with this one?
Yeah, I'm fine.
Right. Again, for S engine, ST approaches pi, you should always say dy dx approaches something. You should always draw that. Representation-wise, that's important. As this, that lah, right? These two side by side lah, either left, either right, whatever, but side by side, please. Okay. All right. Presentation-wise, that will be it. Now I'm seeing your vector question, Yankin, right? So your question is part 3, right?
Yeah.
So are you saying that you do not know D or you do not know E or both? Or
I
what?
do not know part 5, part 3. I know OD, but I don't know.
I take it that you know D, yeah? I take it that you know D lah, right? So looking at the plane OCDE. Right, okay. So origin is the origin, right? So looking at the plane OCDE, this is clearly okay, so OCDE, right? This plane, right? So this plane OCDE will be 5, right? R dot product, right? R0 minus 2 equal to 0, right? Okay. So the normal doesn't have a y component, basically, right? The normal doesn't have a y component. So taking at that B is I and J. So definitely this one is your I and this one is your J, right? Okay. That's the usual assumption, but I just want to make sure, right? And then you have a K, right? So I'm going to assume first that this is K. I'm going to do something about this. So 502 means you 5 here and you 2 here. That doesn't make sense, right? That doesn't make sense. 5, 2. Your normal is like this. That doesn't make sense at all. What's going on here? OCDE. The drawing doesn't make sense. Let me check again. OA is, oh my goodness, because this is the I. So I made a mistake already. This is the I and this is the J. There you go. Right. So now things make sense. 5 minus 2, right? Okay, right. So the normal will be like that. No? That's the normal of OCDE lah. Your 5, 0 minus 2. Okay?
Okay.
Throughout all that, I can confirm that I cannot confirm that it is okay. So I'm happy with that. Okay, now, so to find B, to find E lah. So if I can find E directly, I will do that. But looking at the 2 marks, maybe I can't. So maybe there's an easier way lah. Cartesian plane A, B, C, D. You found. Oh. Yeah, you just cross the plane A, B, D, E and O, C, D, E lah.
What? That's it?
That doesn't.
Because that's the intersecting. Oh.
Yeah. Look, it's a visual topic, okay? It's a visual topic, right?
Oh my God.
So if you don't know how to do that, you do that. Right? Quickly. We don't have much time. Yeah. Look, it's a visual topic. Yeah? It's a visual topic. If I could see it, you could see it also. Just be careful with that. I'm looking at yours, Keiko. Those are physical, blah, 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 you know, yeah, of course. Yeah, a saturated, sure thing, good. There's a lot of thing for calculate the volume of current very good. Okay, so show me what's your concern, Keiko, for this one. Because I see that you have some working here. If you could show me, that would be nice. Ah, my Jamboard.
I tried to use this.
See, yeah.
And I found P1.
The temperature assumed to be the same, right? Temperature is assumed to be the same. Yeah.
I don't think it's correct. I don't know.
So the P1, you're talking about P1 is the one that contains this one, right? This is your P1, right? You just confirm. This is P1. I mean, inside the can, I'm guessing. Yeah. Because this concentration is much bigger than this one. This one is assumed to be under normal pressure. This is the assumption, right? I think. So this is like you open the can and then you let it in there and then you come to end up like this. Whereas this one is like 4 gram per dm cube. So this tells us that this is inside the can. So inside the can, you have this pressure. Good. And then, what is this? What is it?
I don't get this one. Wait, let me. I have very messy working on my paper. Hang on.
Yeah. I'm a bit suspect. How did you get 221.3? Yankin, you're okay, right? You're just trying that one out, right?
Yeah.
And I think you are supposed to use a calculator to solve this, right? Easy. When you're crossing 2 planes, you use the calculator, then everything becomes easy.
And just is simultaneous.
Yeah, simultaneous 3 unknown 2 equation, then you get something, then you have that one out. So that means you're using PV. So let's see. You're using R, T, you're using N. So PV, this is the VV. Sorry, what is this? What is this? Wait, what is that? What is
I'm just using the equation.
Well, how is 300? Sorry. Why is this 300?
Oh, sorry.
It's 5, right? Okay,
yes.
Good. Right. Okay. So I understand. So now this is your. I agree lah. So I agree with this. V1, T1, right? So this is your N. Right? Good. So you have the P. I like it a lot. So this goes from here lah, and then you will be using that lah, basically, right?
Yeah.
So I agree with the volume. The volume, obviously, this one, right? So you want to find P2 because P2 is simply now room pressure lah. Room pressure is just 1 atm, right? Correct. Going flat means you are exposing it to the atmosphere, which is 1 atm, and then you'll get a much bigger volume. I guess that makes sense. Correct. Higher pressure, lower volume. Lower pressure, higher volume, right? That just makes sense lah. So you find your V2 first, and maybe you can think about what to do with it, because that's a lot of hint already.
Yeah, I didn't get this.
But we can get it simply by understanding the question. We need to we need to. The question is not worded nicely but to be fair, we could read it from the question. Again, the question is not worded nicely. No? It's not. Can you accept that P2 is just the normal room pressure? Yeah. Right. Okay, find your V2.
This is from last year's physics knowledge, right?
Do you have? I have no idea whether you should know like this in chemistry. The concept.
Not the value itself.
Okay, let's say you are a chemistry student and you have never studied physics. No way, you could have. If let's say you never take even combined physics, then you'll be a bit confused here, I would say. Yeah, I agree. But I think combined physics is enough if you don't just memorize stuff. But I guess people do that. I guess. Now you don't. I expect more from you. Now where's my V2?
Sun is
I'm so sorry. This number doesn't make sense. This feels more like a KPA. This feels like a KPA. This cannot be this is a very small PA. This doesn't make sense.
Really? Okay.
Yeah, I mean, a room temperature, a room pressure, at the atmospheric pressure is this much, right? 101 kPa. This is much lower than the atmospheric pressure. This doesn't make sense.
That's what I got though.
Hmm.
Yeah, that's why I was so confused.
Yeah, this doesn't make sense. What's going on here? Your R has a missing unit, I think. Has a missing, yeah, your R is a missing something here. I forgot the value of R. Could you check again? This one's fine. This one is fine. This one, I believe, is. Wait, is it the volume that's a problem? Yeah, probably the volume that's a problem. Sorry, even if not the R, then the volume that's the problem.
The R is 8.31.
All right, then the volume. The volume, you're putting it in terms of dm cube. So I'm not sure that's the correct thing even in chemistry, I suppose, because concentration SI unit, I dare say SI unit, chemistry FSI is gram over dm cube. Fine, that's for density also. But for volume, the SI unit is not dm cube.
Oh yeah, and about the density, I'm not even using this value, 1.5.
I know. What I'm trying to say is in chemistry, you're conditioned for dm cube. But the SI unit for volume is not dm cube.
Wait, so
it's
for
m
PV,
cube.
because NRD
is meter cube. It's meter cube.
Okay.
So your over 1000 is fine. You still have to times another 10 to the power of minus 3, right?
Yeah.
So you go for DMQ and do that, and then there you go, you have K. Okay. So Yankin, your line is okay, yeah?
Yeah.
Let me just confirm that you did that with calculator first, because you can and you should do that. Okay, that's fine. If you know how to convert that would be.
I need help with complex numbers simultaneous.
Go ahead. Yeah, that kills people. But if you know how to deal with it, should be fine. Right. So you have your K finally, basically. Right. So KPA and KPA. So you have 2.2 atmospheric compared of versus 1 atmospheric. That makes a lot more sense, I would say. Yeah. Okay. Cool. Okay. 1. Right. Yeah. Right now in here, the 0.5 can stay dm cube, then you'll just get dm cube. This one's fine.
What?
Am I confusing you on that?
This one because it's a ratio.
Yeah, it doesn't matter because then you'll just get dm cube. That's fine.
Yeah,
that's fine. Here you cannot. Here it has to be meter.
Okay.
Are you just doing question part 4? Yeah, no. Well, I'm seeing the complex number. Right? Okay. So are you saying that what are you supposed to do with this?
Yeah.
Is that what you're saying? Right. Now, in the shortest amount of time, the technique that works all the time is what you did. Let me see. Yeah, the technique that works all the time is what you did. You assume that Z is A plus BI, W is plus DI. This but I don't know how to always works. Okay, I'm gonna copy because you did all the bulk of the work already. This is basically the bulk of the work. Assume first that everything is correct. So what you do is something quite simple. You are to extract simpler equations from I would say this. I'm gonna mark that as 4, I believe, and this will be 3 . Okay, correct. Now, look at me extracting simpler equations, which I can then use CG, right? 2A plus C plus 2D equals to 6. from 3 lo?
The real numbers.
To be, do you understand what I'm doing first? Sorry.
Yeah, like find the coefficients of the real and imaginary number.
Right. And suddenly I don't have to deal with complex number anymore. Suddenly.
Okay.
Right? You extract those 2 from here, you'll get 4 unknowns and 4 equations. Not a surprise. Press the calculator, you're done.
Yeah, but can't use calculator.
Oh, do not use a calculator in answering this question. Oh, heck, I don't care. For 4 marks, this. When I say I don't care, I mean I look at my exam. This is 4 marks. This, right? I'm going to write these 4 equations first, and then I'm going to press my calculator just to make sure I am correct first. I will do that. If I'm not correct, I'm not going to waste time because it's very dangerous. This place is very dangerous. It will waste a lot of time. This is not your normal practice, Yankin, when you spend 45 minutes. At most, you should be spending like 12 minutes here. This is too much already, too much for this. So at this point, press calculator, check whether you're correct first, and then I'll tell you what to do if you want to know. Okay, please.
Okay.
Right, please do so first and do it quickly as if you're in exam. Okay, go.
Okay, wait. I think my initial concerns about this question was that like this carbon dioxide, right, is not even like a gas when it's dissolved in water. So like, can we even use the 500 in the first place?
It is a gas one. Gas dissolved in water under pressure. When gas is dissolved in water and we don't imply that it is reacting, right? We are saying that the carbon dioxide is not reacting with the whatever is inside the cola, just dissolve. Then it is still gas. If not, why would it bubble out the moment you release the pressure? You just imagine the bubble being pressured, right, into a smaller bubble, much smaller than what you can see, in fact. But the moment you release the pressure, the bubble grows and gets released out of the cola. It is still gas. It is. So the volume that the carbon dioxide wants to be is 1.02 dm cubed, and that makes a lot of sense. It's almost twice, it's more than twice because the pressure is more than twice during the camp. Correct? Now, Yankin, those are nice numbers. I'm very happy to see nice numbers. Can you check whether these numbers are correct or not? Your calculator can handle complex number. Very easy to check one. So you write this down first. You write this down first. A, B, C, D, write this down, then you check. Okay, yeah, very good. How do you get, whoa, why is it 0.6? Yeah,
that's the answer key. But yeah, we got
no, check one more time. This number is weird. Let me check something. This is almost 1.1, right? This is 2.2. Your carbon dioxide is 44, correct?
And I'm also concerned that we didn't even use the density.
He's saying that let's check one more time. Huh?
So is there like another approach just because of this? And the 2 grams. No, we did use the 2 grams. Just this one.
We did. Let me see for a while. So this is 1.5 gram per dm cube at atmospheric pressure, right? We were assuming, of course, that the room temperature and atmospheric pressure is 1. We were assuming this is 1, and you're assuming that your room temperature is 25, I think. That's an assumption, right? So what do you assume as room temperature here?
In the data booklet, it's 20.
20. Oh, that's why. So 273 plus 20. Right? Those are the assumptions, and I don't think we should. Okay, fine, I'm going to use that. So now for this, now Yankin, you check whether it's correct or not. Check already.
Yeah, it is.
All right, then you have to do the simultaneous equation manually. They are fast and smooth. Okay? And at this point in an exam, I will assume that I get at least 2 marks, maybe 3 marks, and then I'm gone. It's not worth it, really. It's not worth it. I can show you the manual way. For what? None of the topic uses manual way. They just say use CG, AGC. Useless. Useless. Okay?
Yeah, okay.
Okay. Moving on. Of course, we can discuss it, after exam, right? But I don't think we should discuss it now. So, okay, so this is 4 gram per DMQ. I think I'm correct. And whatever ATM that would be, right? No, this is an issue because I'm getting a much number here. Okay, so what I'm getting here will be obviously 4 over 1.5 times 1 equals to, that will be 8 over 3 atmospheric, right? Which is 2.66, right? 2.6 atmospheric, right? Which is slightly higher than your 2.2, correct? Yeah. I'm currently concerned here. I'm very concerned here. I'm currently concerned, but okay, I'll follow that. And then using that, I'll be using my P1V1, P1V1, P2V2. So the only difference I did from you is that I didn't use PVNRT. That bothers me a lot because PVNRT is supposed to be always correct. It bothers me a lot. So now my V2 will be, 2.6 over 1 times 0.5. Easy, right? So what does this give us? 2.6, 8.8 over 3, whatever, 8 over 3, even better, right? So this will be 8 over 6, right? Or 4 over 3, right? 4 over 3 dm cube, right? So this is the answer, key's answer. 4 over 3 minus half is this guy, right?
0.8. Okay, wait, hang on. 8 over 3.
Okay. 4 over 3 minus half?
Sorry, 0.8.
How come 4 over 3 minus half is 0.8? Oh, it is. Wait. But yeah, 1.3 minus 0.5. This is very weird. I have a thing, okay? I have a thing. This is very weird.
Yeah.
I have a thing. So I'm owing you 2 questions, yeah? Ask more questions. Ask more questions.
I have this.
Right. Then I'll take my time to think about it. Right?
Yeah, sure.
Yankee, are you saying that you have no more questions?
I have see, I have the what's it called? The definite integrals, the n rectangles on.
The n rectangles. You mean you use the summation as a basis of integration, right? You're basically using AP. You're basically using G. Yeah, summation of GP, summation of GP.
The sigma notation, all that stuff.
Sigma notation, n to infinity, basically. That's okay, yeah. So what about it?
Give me a second to put the question up.
Right. We have time. Okay, cool. We have time. I'll take my time to think about it. So. Assuming the volume Oh, about volume of the balloon reaching. Okay, that's fine. This question is not practical at all. It's very weird. But okay, all right. Yes.
My question is that I'm not sure. So this is like my summation, right? But I'm not sure how I can get n cubed, 1 over n cubed. You see on the outside, 1 over n cubed.
Okay, I'm looking at it. Sorry, you're talking about part 1, is it? Oh, part 1.
Yeah, part 1, the n 1 over n cubed. I only got until here, 1 over n.
I'm looking at it here. So he want this, the inside he want it as a function of R, right?
Yeah, so it can be anything, but
I don't think that's what it means. At least I don't think so lah.
like R goes to 1 and continue from there, right? So
Like for example, look at me doing something, yeah? Look at me doing something. So I'm just going to casually okay. The inside, I just take out the 1 over n, right? And I'm able to do the same thing. I'm just taking 1 over n out casually.
Then 2 plus,
right?
2 plus n.
2 plus n, yeah, 2 plus n square. And then I realize that everything can be done like that. So 1 over
then you
n
apply
square
on both, so 1 over, oh.
Like I said, I think this is meant to be that lah.
So
I think that is meant to be like that. So I need to make the inside like that, and therefore that's my 1 over n square lah. Okay.
Oh my god. Okay.
I don't think it is anything lah. I think that's the mistaken part. Yeah, I think the reading, your reading is mistaken. Yeah. Assuming that the volume of the balloon does not change, calculate the maximum internal pressure in the balloon. The maximum internal pressure of the balloon at the height. Assuming the maximum internal pressure using determine whether the balloon will burst the height. However, okay, so Keiko, I've read your answer key and the question one more time. Yeah? So my answer won't be very satisfactory to you. I think the consolation, and this is just 1 mark. I'm being very practical here, right? So we shouldn't be spending too much time in this, okay? Right, so if I follow the answer key don't use 2. That bothers me a lot.
Don't use 2. Oh, the 2 bar.
Yeah, it does not. In any way, it does not. Right, in any way, it does not. Right. Secondly, knowing 2.84 minus 0.28 is, I think, useless. In fact, this is your 1 mark, right? So this is not useless. For the sake of the 1 mark, it is not useless. But knowing 2.84 and therefore knowing that it is more than 1.99 is a little bit useless practically, because that means the balloon will burst before 1,000 meter, over 10,000 meter. Correct?
Yeah.
So I feel that the question is missing out. The question is missing out on that. I feel if you just focus on this, it is nice to know that, right? It is nice to know first thing first lah. But I don't think it makes a lot of practical sense. And secondly, who is using the 2 bar? Wait, nobody is using the 2 bar. It's very weird. But the weirdest thing for me is that this is only 1 mark and this is only 1 mark. That's the weirdest thing for me.
I see. So
I find too many weird things here, and I will not bother with too much. I feel. Okay. Right. Apologize, but that means I agree with you, lah. Formally, I agree with you, right?
Okay. I have a question.
Yes.
Do I expand it like that or like that?
Part 2, yeah. Given that R, okay, is given as.
I'm not sure if I can just replace the R with R plus N, and that's how it works. But or if I have to do this.
Oh, yeah. Okay. The N is a number, right? The N is a fixed number, but however, you're running the risk of.
I don't know if this is like at all a thing.
Look, in doubt, because in exam, let's say you don't have time to experiment or to find out, the safest one is the second one. The first one, you're doing some assumption, you need to confirm that before the exam in order to take that. So you take the second one, and the second one doesn't seem to be too difficult to handle, to be fair. Right?
So N is a constant.
Right. So N is a constant. You can pull it out, right? You pull out the 2N. It's easy enough to handle the second guy in order to not justify the first guy. Make sense?
Okay.
Right. Okay, back to your question, Keiko. So, Keiko, just to confirm, are you sure that this part 4 has nothing to do with 1, 2, 3?
No.
All right. Okay.
Yeah.
All right. Understand. Let me think carefully. Yeah. Maybe there is a point, maybe. Okay, Keiko, would you help me with something? Press your calculator for the PVNRT, but replace the 2 with 1.25. Just change this to 1.25. I'm not trying to, sorry, I'm so sorry. Am I trying? No, I'm so sorry. I'm so sorry. Bad request. Sorry. My request is instead to find the V, right? So nRT over P. So the P will be your the under pressure. Under pressure. So let's use two. Wait, that doesn't make sense. I think I've got. No, I don't need that. Sorry, I don't need that. All right.
I got this with this one.
With what? Sorry?
I got this answer with this pressure.
What do you mean? Sorry, what do you mean?
Oh,
you mean the PV and RT like just now, the V, is it?
Yeah.
Correct. Yeah. So 1.25 gram. I know the R, of course, the T, of course. The P is room temperature because your room pressure because you're expanding, and then you want to find that V in. Yeah. Okay. So there's only fair, yeah, fair. Okay, fair. So I'm going to explain what I did first. I basically use this. So how do I use it? Very simple. Because by comparing this and this, it already tells me how many grams of carbon dioxide will escape. Very simple. Because 0.5 dm cube, half dm cube can only handle 0.75 gram by right in room pressure. Right? This is
you multiply.
I basically just find 1.5 times half lah, so 0.75 lo. That's what I found lah.
Okay.
Then I already have the excess carbon dioxide, which is 1.25 gram lo. This is the excess that will certainly be released if it goes flat. There is something else going on here, but if this makes sense, that's why the 1.25, PVNRT, you get the V lo.
Okay.
So maybe I was wrong when I follow your working. I was assuming that the cola doesn't matter.
I had a feeling mine was wrong. Yeah.
And what makes it wrong is perhaps because the can does not just contain carbon dioxide, it contains cola also. That means the water and everything in it. So that should have that should have influenced our PVNRT until we cannot handle it with just PVNRT, right?
Yeah, that's why the 500 and the
yeah,
carbon dioxide.
And then this thing is given so that we can go and simply find the N, the M. Then we can convert it to N, and then we can use our normal PVNRT, because when they release it, it is no longer bound to the cola, so we can use our normal PVNRT. So I answered your question wrongly just now. The carbon dioxide inside cola shouldn't be considered ideal gas. Obviously not. Obviously not. I'm sorry.
Okay.
Yeah, that part. Only inside air can it be considered ideal.
Okay.
Yeah. So, right. Nothing else for you, Keiko?
Nothing else.
Right. You can hang around. If you want to do other thing, also fine. You can also go offline. I'm just going to help Yankin.
Yeah, I think I'll just go offline.
Good thing. All right, Keiko.
Thank you.
I'll see you on Thursday. Yeah.
Yeah.
Bye.
Bye-bye.
Okay. How is it, Yankin?
I'm not sure what limit n to infinity is. I also don't know if I want to expand it like this. It's very messy.
I'm just following your working. Right. So the key is n approaching infinity, right? N approaching infinity. So we have to be able to handle this with whatever our expansion throws at us. So so that we don't waste time, I don't simplify. Right? Meaning to say, I'm not sure what to simplify. That is your question, man. What am I supposed to simplify? Am I supposed to deal with this? Because at this point, wait a minute, maybe what you did might have some use actually. So I'm just gonna. So because I realized that my n is infinity, during limit n to infinity, I try my best to. Okay, let me put it another way. So let's say I'm stuck. Let's say I'm stuck here. Wait, no. Let's say I am. Let's say I only do this one, right? Okay. This is difficult to handle because 1 over infinity by right is supposed to be 0. But I also have infinity here, right? So this kind of bothers you. So looking at this, infinity over infinity only makes a lot of sense like this. If the top guy has less infinity than the bottom guy, it's just 0, keeping it simple, right? So that's why this part and this part, coming from this part and this part, they will be 0, right? But this part will end up with 1 over 3 because there is no n to consider. So I think your 1 over 3 is great. First thing first.
Okay.
And this is gone in a sense that that's how we deal with n approaching infinity, right? Now, same thing with what's going on here. The n over n square will just be gone right now because n approaching infinity. So this guy is gone. But n square over n square, both n gone, then suddenly I have freedom to simply consider 2 over 2. Right?
Oh, so it's 1.
So there's a 1 here. So 1 over 3 plus 1 plus 1. I believe that would be the answer. 2, 1.
Oh. Can you explain this part again?
Right. Yeah. So only this part, yeah. So I'm dealing with this the same way as you're dealing with that. Actually, you are already doing it. So I just feel like because you stop short of, wait a minute, what am I supposed to do? That is actually a good question, right? At least you ask it very fast, You don't wait for 45 minutes. So the reason why I'm going to now deal with it, okay, this is just cross. It's always gone, right? Right. So basically, you just have 1 over n plus 1, correct? Basically, you could have written that, right? You could have written that. But the important thing to know is that 1 over n is gone. And that's why we want 1 over n, basically. No? So you can say that we want this guy, we want this guy, and we want this guy, because we can make a conclusion, and voila.
Okay.
Right. Now this is quite normal. I feel this is quite normal to do. This is an important skill to know, right? Okay. All right.
Yeah.
Do I owe you anything else?
I don't think so.
All right. Okay. Now, part 3 is a verification. It's 1 mark because the integration is very easy. I think you should take that 1 mark because that's confirmation. That's the benefit of part 3, not for the 1. Do you understand what I'm saying?
Okay.
Right. So integrate this quickly.
X plus 1 squared.
Yeah.
It is. I need to think about this. Okay. 1/3. Wait a minute. X plus 1 is just 1, right? So isn't it just 1/3 x plus 1 cube? So
yeah, remember you can always differentiate back to confirm, right? You can always do that.
Yeah, it is.
Right. Good. Now this is not verification. Then what do you do?
I need to. So this is 1 to 0, right? So 1 0. So
it's called 0 to 1. Yeah. However, you do it correctly. Yeah. It's not 1 to 0. It's 0 to 1. Yeah.
Okay, 0 to 1.
The bottom to the top, right? Then
1 plus 1 is 2. 2 cube. 2 cube is 8. 8 minus 1.
7 over 3, right?
Yeah, so
it's correct. Yeah.
Okay.
The value of the part 3 is to confirm that you are correct. Good, right? Your presentation for part 2 is lacking. Yeah? You should say that after that final line, you should write estimate. So approximately 1 plus 1 plus 1 over 3 lah.
So
yeah, after that you approximate. Yeah. So as limit n approaches infinity, that guy will approach, with the 1 over n cube. You seem to forget the 1 over n cube. Yeah?
Oh.
Right. Then this will be an approximate sign instead of equal sign. Approximately 1 plus 1 plus 1 over 3 lah. Which is 7 over 3. Right. That's the final presentation.
Okay.
All the best for tomorrow. I will see you on Thursday. All right. Bye.
Bye.